limits involving infinity. What the hell does that mean? All right. So remember, we talked about three strategies we could use to tackle the indeterminate form, which we said was 0 over 0 or infinity over infinity. Well, in this case, we have infinity over infinity. Plugging in infinity for x, we get infinity over infinity. So we do not know what the limit is as of this moment. So tackling problems with infinity usually involves dividing by the highest power of x in the denominator. So looking at this, the highest power of x in the denominator is actually x squared. So I could say the limit as x approaches positive infinity is going to be 4x squared divided by x squared minus 5x divided by x squared plus 1 divided by x squared. And this is all over 5x squared divided by x squared minus 3 divided by x squared. Now at this moment, all we got to do is just cancel. All right. So this is just 1, right? Because x squared cancel out with x squared. Right. So I'm just going to rewrite this as the limit as x approaches positive infinity of 4 minus, well, one of these x's are going to disappear, and this is just going to be an x. Right. So this is an x. This is a 1. All right, so this will be minus 5 over x plus 1 over x squared because we can't do anything right there, right? And that's going to be all divided by, well, x squared and x squared cancel out. So this is just 5 minus 3 over x squared. Now here's the problem. Now we do not have an indeterminate form. What dividing by the highest power of x in the denominator does is that it prevents the denominator from going to 0. And so you could think of it as this. A constant that just stays a constant, never gets bigger, never gets smaller, divided by a really huge number is not 0, but the limit of that is 0, right? So negative infinity, so if you plug in infinity over this is, but the limit of this is basically going to 0. Same thing for this, going to 0. This also going to 0. So the limit of this function is actually 4/5. Yes, right? Let's tackle another one. Limit going to negative infinity with this one, divided by highest power of x in the denominator again. So the limit as x approaches negative infinity is 4x squared over x cubed minus 5x over x cubed plus 1 over x cubed, and that is all divided by 5x cubed over x cubed minus 3x over x cubed. So cleaning this up, the limit as x approaches negative infinity is actually, well, 2 of these go away, so this is just 4 over x, right? Yes, right? Minus 5, well, 1 goes away, this is 3, so this is 5 over x squared, yes, and this stays the same, plus 1 over x cubed. I can't do anything about that. And this is divided by, well, this is just 5, x squared, x cubed and x cubed cancel out, minus, well, one of these x is going to go away, so this is going to be 3 over x squared. Plugging in infinity now, right, because this is now no longer infinity over infinity because of this 5 in the denominator. So the limit of this is 0. 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 Right? So the limit of your whole function is just 0 divided by 5. And any number divided by 0 is just 0. Try another one. Alright, so looking at this limit, the limit as x approaches 3. I am sorry about this. This should actually be infinity, positive infinity. Alright, so the limit as x approaches positive infinity of this function. Alright. Well, I'm looking at this and say, well, can I factor? What can I do? There's nothing I can do. I could plug in infinity and see what happens. right? So if I plug in infinity for this, infinity squared is just really huge. Times 5 times that is really huge. And 8 minus that will not be a negative. It'll still be positive infinity. You see? It'll still be positive infinity because this is squared times 5 times that. It's just, this is so much smaller, so it won't make a big difference. So this answer will still be positive infinity. And let's look at why. For those of you who are visual learners, we could graph this, right? Remember, the end behavior of a function is always determined upon the leading term coefficient. So this x squared right here. So remember, whenever we have something odd, the function looks something like this. Yes? Even, the function looks something like this. When it's positive, when it's negative, it looks something like this. Yes? So just going by this, well, the leading term coefficient is positive and it's a squared. It's even. So this is a quadratic basically. You see? So as x approaches, think of it as x going to positive infinity, the y value is also going to positive infinity. Right? Hence the answer is positive infinity. Let's look at this one. Negative 3x to the 5th power plus 4x squared. Going to negative infinity. Well, again, you could plug in negative infinity in this and think of it logically. But I like to use visuals. And remembering what graphs look like, the end behavior is determined just by the highest, the leading term coefficient, and its power of x. So this is negative. The leading term is odd. So I know my function is going to look something like this. However, the negative sign here flips it over. So it looks something like this. Yes? I do not connect the middle because there could be a bunch of stuff going on. It could be crossing, touching, so it doesn't matter. So the limit as x approaches negative infinity, you can see the y value approaching positive infinity. So the answer to this is positive infinity. Let's look at this one. All right. This again, a negative term coefficient, so I could draw this out. And again, I'm not stopping you from thinking of it logically. I'm just trying to use proof here to show you why the answer is what it is. So this is 2 to the 4. This is odd. So this looks something like a quadratic, but the leading term coefficient is negative. So I could assume this graph looks something of this nature. Yes? So as x approaches positive infinity, the y value is actually going to negative infinity. All right? So the limit, sorry about that. So the limit is actually negative infinity. Now let's look at what is happening really. In algebra, we essentially are finding the horizontal asymptote, right? So the limit of this is actually 4/5. Well, the leading term coefficient is 4/5. Now, remember the rules of algebra. The rule says that, okay, well, if you have x squared over x squared, or it could be x cubed over x cubed, and I'm just choosing some arbitrary coefficient. So this is 3x squared, and these are the leading term coefficient, plus 1, and then I can say, minus 2. All right. Whenever you find a horizontal asymptote, if the leading term coefficients are equal, we take the ratio. So the horizontal asymptote is actually 3 thirds here. Three halves here, which is what we determined in the first problem, which is 4/5, but you get the idea. With the second rule, if you have the numerator being bigger than the denominator, just by 1 in terms of the leading term coefficient, all right, your horizontal asymptote is actually 0, right? We say y is equal to 0. That's just a rule. It's the same thing we saw here. So before doing this problem, I know the answer is going to be 0. Now, I am a student just like you guys, so I know the instructors are going to want you to prove it algebraically, but in fact, you could just know the answer before you even tackle a couple of these problems. So that's the trick. And then the last rule says that, well, if the numerator is bigger than the denominator by 1, you have no horizontal asymptote. None, right? You have an oblique asymptote, but that's besides the point. You have none. And so in this case, a little trick here for you guys. In the none scenario, the limit is gonna follow what your infinity as x. So your infinity. So say for example you have something like this, right? And some coefficients. And you have the limit going towards positive infinity as x approaches positive infinity. The limit will follow the x coordinate, the x value. So the limit for this will be positive infinity, right? Same thing. If the limit as x approaches negative infinity of some arbitrary function with the coefficients being different by 1, with the numerator being bigger than the denominator, the limit is going to follow the x value, which is just negative infinity. And I will make sense of this concept in the next video.